Hello dear students, in this particular video we are going to learn forces between two parallel current carrying conductor. So let us take two conductors of infinite length and both are placed parallel to each other at a distance of, let us say, r, and current in them I1 and I2, let's name it as AB, and this one is CD. Now since it is infinite length, so this wire will produce magnetic field, and the direction of magnetic field onto this side of AB conductor will be perpendicular to the plane and inward as per right hand curl rule. So the magnetic field we can write here, the magnetic field produced by current I1 at any point on wire CD is given by B1 equal to mu naught into I1 upon 2 pi r. Now this field is acting perpendicular to the plane and going inward, so we are representing it by cross. Now we know that this second wire, CD wire, is having current I2 and it is placed in the magnetic field which is produced by the first wire. So the force acting on length, the force acting on length L of the wire CD is, force will be I L cross B, we know I2 L cross B, and if you take I2 L vector and B vector, both are perpendicular to each other. So B is B1, and we have taken some finite length of conductor CD. So I2 into B1 into sine of 90 degree. The angle between L vector and B1 is 90 degree. Sine 90 is 1. So it is I2 L B1 magnitude. If you put the value of B1, I2 into L mu naught I1 by 2 pi r. Now if we write mu naught I1 I2 by 2 pi r into L, so this is the force acting on the second wire CD, and the force per unit length we can write force per unit length, that is F2 by L mu naught I1 I2 upon 2 pi r. So this is force on the wire CD on its unit length, force per unit length. So now we are going to calculate the same force on first conductor. My dear student, you can see due to this CD wire, since it is carrying current I2, they will produce magnetic field at a distance of R, and here the direction of magnetic field will be dot, perpendicular to the plane and outward. Again, if you will apply IDL cross R, it is perpendicular to the plane and outward. So force, or you can write magnetic field produced by current if you want, we can show the direction of the force. So ILB, force will be perpendicular to L and perpendicular to B. So IL in this direction, B perpendicular to the plane. So if you use Fleming left hand rule, we can calculate the direction of force by using Fleming left hand rule. The direction of force on this second conductor CD, current is in this direction, magnetic field is perpendicular to the plane and inward. So open the forefinger in the direction of cross, central finger in the direction of current, then thumb you will see it is pointing in this direction, and that will give you the direction of force F2. So on CD wire, the force is acting towards AB wire. Now magnetic field produced by current I2 at any point on wire AB is, so magnetic field will be again B2 will be equal to mu naught I2 by 2 pi r, because CD wire is again of infinite length, so this is the magnetic field due to infinite length wire. And now the force, since this first conductor AB carrying current I1 is placed in magnetic field B2, which is produced by CD wire, so force on length L of wire CD, not CD, of wire AB. Now on AB we are calculating force. So F1, that is IL, and I is I1, IL cross B2. Again that direction between L vector and B2 is 90 degree only. So if you put the value I1L B2 sine 90 degree, which is 1, I1L B2, and now putting the values I1L and B2 is mu naught into I2 upon 2 pi r. So if you multiply mu naught I1 I2 upon 2 pi r into L, so now force per unit length we can write force per unit length F1 by L, which is mu naught into I1 I2 upon 2 pi r. The direction of force F1 will be again Fleming left hand rule we have to use. So if we point the forefinger of left hand in the direction of dot, central finger in the direction of current, then thumb is going to point in this direction towards conductor CD. So this is force on first conductor, and on this conductor the force was acting in this direction. So when current in both the wire is flowing in same direction, in that case the two wires apply force of attraction. So force nature will be attractive if current is in same direction, if the current flows in two wire in same direction, the opposite point will be like, if the direction of suppose current is reversed, I will be explaining that figure also. So point note wise we are going to observe, suppose I1 and I2, the first case when they are flowing in same direction, so force is of attraction type, attraction, this will be attracted towards this and this one will be attracted towards first one. Second possibility, in the first conductor current is flowing, let's say in opposite direction to the second one. Here it is I1 is reverse to previous case. So force on this one will be in this direction only, but force on this one will become. Now we have to check. We cannot directly say. So let's see what will be the direction of force. We have assumed the current as I1 and here it is I2. So due to this current, the magnetic field at this point, when the current was flowing upward, here the direction of magnetic field was cross. Now it will be dot. So magnetic field is perpendicular to the plane and outward, and current is flowing in the upward direction. Now if you apply Fleming left hand rule to find the direction of force, so that will be magnetic field is in the perpendicular direction, current is in the upward direction, right? So ideal cross B. So ideal cross B, so it will be acting in this particular direction. Earlier it was left, now it will be acting in the right direction. This is force on 2. And what about the magnetic field due to this? It will be dot only, and here the direction of force will be ideal cross B, so it will be acting in this direction. So opposite direction will be force of repulsion. If you apply Fleming left hand rule or right hand curl rule, you can easily get that. Okay, suppose here current is like this and in this one now it is reversed. So in this case, due to this wire, the magnetic field at this point will be cross, and ideal. So if magnetic field is reverse, it will be force will also get reverse, and due to this current, the magnetic field at this point will be cross. So here magnetic field is reversed. So if magnetic field, but current is also reversed. So ideal cross B. So the force will be acting in this direction. Okay. So here both the forces are acting in the, this one we can verify it. What is the direction? Ideal cross B. So it will be perpendicular to the plane and it will be in opposite direction. Okay. This one was wrong. So this will be the direction of force. So here these two forces are again repulsive in nature. So what is the observation? If the direction of current in both the wire is same, then force of attraction, and if direction of the current in both the wire is in opposite direction, then force of repulsion. Okay, and force per unit length, fourth point, whether it is F1 by L or F2 by L, it is mu naught I1 I2 by 2 pi r only. Thank you, Vicham.